Miss Navjot Singh Babra, and today I'm going to use superposition theorem on my circuit B. So let's take a look on my circuit B. Here we go. So this is my circuit B, which having the two sources. One is the current source and one is the voltage source. Let's look our circuit B, which having the values for all R's, and here we go. We have a source 1 which having the 2.4 milliamp and source 2 which having the 8 volts. So superposition theorem is usually based like we have to take one source in each step and another source in another step, and we're gonna combine our values in final. So here we go. We just taking source 1 and removing source 2 by just having the wire, and we figure out the R total across these resistors, and this is our R total, which is 3.1 kilo ohm, and we can figure out that current is same in these two resistors. So by current is same, which is 2.4 milliamp, and we need to find the V total to getting the VDR. So here we go, we find the V total, and now we having the R equivalent, and which is this, and if we find the voltage across this, we find the voltage across these two. Same we did here. We apply the voltage divided rule, and we getting the voltage for these two and these two resistors. Now if we having the voltages, and we can find the I, just having the Ohm's law, and we're gonna find V by R, and we got our I for our circuit A. So here we have a look in our OR circuit. So this is our first step. Here we having the one source, which is our current source, and we remove the voltage source, and we getting the same values here. So let's look our source second step, where we remove the source 1 and we just having the source 2, which is our 8 volt source. Now we're gonna see, we simplify this 8 volt source, and we having the two equivalent resistors. So this is our R equivalent A and R equivalent B. So now we having we call this figure B. We find that R total, V total, and now we just find to need I total, and then we finally get our values. Just we solve this circuit, we need to find the I equivalent A and I equivalent B, and then we can easily find the V across all these resistors. Here we go. We did here, we find the I for this, and we can find for this, and we look here, these are in series, so I for this is same here and same here, same we did, and for I equivalent A is I equivalent B. So now we know that I is same, so we can apply the Ohm's law to get our value for V. What we did here, we just I into R and I2 into R2, and we having the value for our I, and same here for V. Let's take a look in our final circuit. Oh, it's a little dirty, and we having the direction here, which is a clearly indicate that for our R3 and R4, and this is our R1 and R2. Here we're gonna see for the R4 there is opposing direction, same for the R3, but in the case of R2 and I2 we having the same direction. So that's so simple. So we cannot just add the voltages for R1, R2, and just we're gonna minus the voltages for R3 and R4. Same we did for our I. Here we go, and this is our figure B, where just we having the one voltage source, and we getting the same value we found in our circuit in our calculation. So this is our tables. So for figure A and figure B, this is our calculation for figure A, and this is our calculation for figure B for VI and P. And for final circuit, we just need to add our source 1, source 2, and we got the values here. And this is our OR. So this is a clearly indicated that we having the both source, and the value is kind of similarly same, but they are not so equal, but they are same. And let's look. Here we go. So we done with our source 1 and source 2, and we got in the same value for our OR. Thank you.